Good afternoon, everyone. Thank you for joining us. This is Jesse Reutenberg of Stratasys. Today we're going to take you through things you should consider when thinking about setting up an academic lab or makerspace at your school. No matter what kind of educational institution you're at, there are things to consider when researching and planning 3D printing labs. We're going to chat with you about some of the best practices that we've identified, and we've asked one of our top customers, St. Cloud State University, Kurt Helgeson and Chuck Henches from this university, to join us and discuss. The Environment and the Technological Studies Department at St. Cloud State University is where Chuck and Kurt reside out of, and they've been a user of 3D printing for 10 plus years. They started slowly with us with some of our Uprint systems, and have graduated to have some of our higher-end Fortis, our PolyJet, and now our F-Series pieces of equipment in their makerspace. So they know the growing pains, they know the ins and outs of what are good and bad to do. 3D printing labs give students a space to learn, explore ideas, test designs, and solve for real-life problems using technologies that they're becoming industry standard. High schools, colleges, and universities all over the world are investing in this endeavor. We'd love to help you learn about how you can too. 3D printing labs benefit schools in a variety of ways. It encourages STEAM exploration on industry standard equipment, creates and offers student opportunities for workforce development, reinforces what is taught in the classroom with hands-on applications and experience, positions schools to be in the realm of cutting edge, powers iterative design and best-in-class research, opens doors for partnerships opportunities within the community and local businesses, and inspires design thinking and problem solving among students. The things we believe you should consider when planning your 3D printing lab include your audience, the applications, your vision, the space, and the ongoing operations. The size, shape, and purpose of your lab depends on entirely the goals you've set before you. It really dictates how you begin your construction or iteration to an existing facility, and it's different at every school. With that, I'd love to get some input from Chuck and Kurt on how they've developed their lab.
Well, thanks, Jesse, for having us here today. At St. Cloud State, a lot of different considerations went into the planning phase. There are also quite a few different things we wish we'd have dug deeper into at that time, and we'll be explaining those as we go along, kind of some of those best practices that you've listed.
One of the first things we recommend thinking about is your audience. A few questions that come to mind right offhand are, who will be using your 3D printing lab? An obvious answer is students. But what about educators, the community, local partners? Within your school, which classes and departments would have access? All or a select few? Will personal projects be encouraged? Once you've identified who, we need to think about how many and what the capacity to meet demands would be, or expectations of those capacity demands as you grow.
Yeah, so we identified the different departments and students using the lab for courses and curriculum work to be the number one priority. We also had over 9,000 students use our lab last year from other schools, as well as all sorts of other departments within our own college, science and engineering, as well as our Department of Environmental and Technological Studies. But we've also had a marketing department, the communications department, to name a few. Second of that, students general use for personal projects, for student clubs, for things like that, as well as their senior design projects. Lastly, the business community and local partners came to mind. Our audience and our capacity to meet our external demand all influenced how we marketed our lab once it was open as well. The list we have created directly ties to the purpose we had to identify for our lab, which is another thing to consider.
I think it's a huge question to ask yourself and the rest of the colleagues that are thinking about 3D printing in the lab is why. Why do you want it? As Kurt just said, define the original purpose. We know from experience that there is growth, so sometimes you have to readjust or expand those purposes, but having an original purpose is key. There are a lot of 3D printing materials and systems available out there. Being clear about the goals of your lab and your students will help you nail down the right solution. Another thing to keep in mind with the 3D printing system is the software. The software you choose to use will impact the 3D printing process from start to finish. Once you narrow that down, but before you even purchase a 3D printer, we suggest ordering or requesting sample parts to understand capabilities, reliability, output, as you can see, and compare those to the different systems out there. They vary. You still get what you pay for in 3D printing, but there are a lot of opportunities to evaluate. Plus, samples are a great way to demonstrate the value of possibilities of 3D printing to any of the key stakeholders.
The way I like to describe or explain this step is to think of it the same way you'd think about adding another computer lab. What is the reason? What is the problem you're trying to solve by adding and incorporating this into your school? For us, we've investigated 3D printing into a few of our college courses in a variety of departments, creating community outreach programs like our mobile lab for our K-12 partners, and encouraging all students to use the Stratasys 3D printer and GradCap software. We also have a few clubs around the campus that have found ways to use a printer, like our Formula Race team and several other clubs across campus.
I love the fact that that Formula Race team has reached out to us multiple times to assist with the donation of materials, and to see what they've created is powerful. Those are the type of students we actually look at hiring, as they have the real world experience that we like. The vision you have for the space, the future you see unfolding for it, will impact a lot of things we've already discussed. It will tie into the original purpose you've defined and expanded. How do you foresee the operations and management of the lab unfolding? What are your expectations for future growth? What are the future opportunities for your lab?
Well, we're still growing our applications and figuring out the ways to meet the increasing demands of our Makerspace. An idea we have, but haven't entirely began trying this, is using the labs as a revenue stream. Your 3D printing lab could potentially double as a service bureau for the businesses in your community seeking out 3D printing advice or services. It's something I would recommend focusing on after the workflow is established and proven to be functional, but can help with the future sustainability of your program. And what we've been able to do is really identify one or two companies locally to really test that process so we can understand the workflow. And it's working well before we really promote it to the community as a whole.
I bet those companies like that, because then they get some experience with those students as well as potential employees in the future. We know space is a huge factor as well. When thinking about planning to set up a 3D printing lab, there are a lot of things that need to be considered. Flexibility of the space for growth, power, data, ventilation, cooling, water, air, vacuum, post-processing, design software, computers, space for group work and collaboration, storage, and a space for each printer. As you're planning the layout, check with your facilities managers to make sure the space you've designed is set up with the right ventilation and power it will need to operate safely and efficiently.
For us at St. Cloud State University, it was important to use a startup to finish mentality to really get a grasp on the workflow and how that would all happen in the space we had. We decided it was necessary to have computers in close proximity to the 3D printer so that could remove a lot of the runaround by students and staff using the lab. We used a different room for our cleaning and post-processing stations, knocked down a wall to accommodate for power requirements, and make sure the air conditioning we had available in the 3D printing space made up for the heat that was generated by all the equipment. Storing the materials, build plates, and other things needed that is used by the 3D printer also comes into mind as something that could have been easily overlooked, but should be thought out early on, because you want to make sure that these things are readily available to students and staff running the using the lab. Having a humid-free area where storing our materials is a big priority of ours right now.
Yeah, that is a big piece to know for those using the FDM processes. Humidity is not we're not a fan of humidity, but knowing that it is key. And we've seen people set up labs in different ways or have different mechanisms to keep that material dry. So if you have questions on that, do not hesitate to ask your Stratasys partner or Stratasys. What happens to your lab now once you have it? What do the ongoing operations look like? To narrow that down, a few questions to ask yourself are, who's going to run the lab? You need to have a knowledgeable operator to oversee the workflow and operation of your 3D printers, especially when you're talking about addressing thousands of potential clients, students, or projects. Think about planning for how you have to handle the ongoing support needed. There are maintenance costs to these pieces of equipment. There is costs for materials. But having those paid for absolutely lead to basically fearless printing, not worrying about that next step if something goes wrong. So that workflow can definitely help things move faster and more efficiently once your lab is up and running.
This is an aspect that we've seen overlooked in many cases or an afterthought. For us, we staff our lab with students. It's given us the ability to create advanced learning opportunity for our students who have a strong interest in 3D printing. It also gives us the bodies we need to handle the stream of printing jobs that come throughout the day, different times of the semester. We have different loads. So planning to handle material usage, service contracts, and repairs. Don't forget about to research and learn about the machines you decide on. For example, how do you keep your printer heads clean? Not knowing details like that can lead to more repairs, replacements, maintenance needs, downtimes, ultimately affecting the capacity of your labs. And so that really comes with the support, from Stratasys and the distributors and things like that, making sure that you have that support to answer those questions when you do run into problems.
Yeah, I agree. I would say the majority of our issues with equipment comes after the summer break when people haven't done their due diligence, removed materials, put it in a secure spot, and they come in and start to print, and they get a clogged head or something. Yeah. So 100%, there are so many ways to proactively ensure that your equipment is safe, secure, and working. One thing I want to comment on is that the pictures that we've seen in this webinar are beautiful parts from your guys' lab, from your students, from your projects. Really exciting to see the growth of how you've come from, mostly working with the students and even the high schools that have more, less advanced projects to where we're at now. It just goes to show you the growth of what is being taught, what is being understood at that high school level, and when they get to that university level and college level, the capabilities that these students have leads to an expectation that a lab needs to be more than a couple low-end printers. It needs to have some professional equipment. With that, thank you so much for walking us through that, Kurt and Chuck. And to all those watching, listening, we hope this information is useful on your journey to setting up a new 3D printing lab or expanding your existing lab today. To summarize, we'd recommend thinking about your audience, your applications, the future vision of the lab, the space you have to work with, and what is available, and the ongoing operations and management of your academic lab while you're setting up or planning it. For more information about setting up an academic lab or makerspace, download our guide at stratasys.com or contact your local representative of Stratasys products. Thank you, and have a great day.